about the introductory stuff regarding temperature and CO2 and phytoplankton in some places. Go for it, Nicole. We'll look forward to this.
But that's high expectations. Well, like I just said, I'm here to talk about the some introductory things for the paper. Basically, what I'm going to go over are some key terms. I'm going to talk a little bit about the equipment, and then I'm going to talk about diatoms versus nanophytoplankton because they're kind of an important thing. Alright, so first of all, one of the abbreviations in the paper that came up a lot because it was one of the measurements was the sea surface temperature, which I figured everyone should know what that abbreviation is, just in case I didn't know. But that's where they took the sea surface temperature is basically from all of the samples because they could only take things from the surface layer. Community structure, which was one of the other key words, is basically defined as like a large group of different things that can be put into like subcategories. Like they're all basically connected, but they're also like they can be separated but still connected. One of the other things was the plankton dynamics, which are basically defined as like their primary productivity, which their primary productivity is defined as their gross production, net production, and standing crop. The continuous culture, which they had like constantly going, so that way things would be able to have basically they had it going so that way they could have a constant thing of bacteria and such going through. But it's the technique for production of microbes and microbial products in which nutrients are continuously supplied to the fermenter. The fermenter is one of the things I'll talk about a little bit later, and irradiance, which was on one of the graphs, is basically the flux of radiant energy per unit area, and so basically when the light shines through, it's like everything that's reflected in there. PCO2 equilibrium is like the partial pressure or the tension, and that's mentioned several times throughout the paper. One of the things for equipment that they used was the trace metal clean in Teflon pump system. They did this basically the way that the trace metal clean pump works is it allows them to take the different samples and be able to get it without having anything be contaminated. Pros are you can do that pretty well and still get a bunch of the different metals and such out of it. The problem is you can't put that very low because otherwise it will clog the pump. But one of the bright sides about only taking surface sea samples is the fact that that's basically the only thing they were going for because that's where the phytoplankton are most prevalent at. The other thing was the fermenter, which was how they had the continuous culture going, and basically it allows them to circulate the microbial products like throughout the system constantly. Don't ever try to look up pictures for them because you can never find them. Really, really hard. diatoms versus nanophytoplankton. We've all kind of heard about diatoms more than once, but one of the more important things about this is the fact that because of like the study showing that like it went from a more dominated diatom system to a more nanophytoplankton system, it's important to kind of understand why that's important, and a lot of that is because while they're very similar in like what eats them, there are a lot more things that actually feed off of diatoms directly than on the nanophytoplankton, such as like crabs, shrimp, snails, and zooplankton. And they have the different algae blooms. So that's like, when that happens, it's like a major source of energy toward like the ocean. So it's a lot of things that actually eat these. And basically are also kind of they're kind of a showing of how many different nutrients are actually in the water, because one of the things that I kept noticing whenever I was looking them up was how people were like, how do I get these to stop being all over my aquarium tank? So, and that was basically because there were too many nutrients in the water there. And nanophytoplankton are mostly eaten by krill and also zooplankton. I couldn't really find anything else that was directly eating them. So mostly they're the first step of the food web as well as diatoms, but in this case, like krill obviously is like eaten by whales. So generally it's kind of more, or like, yeah, this is a direct thing that eats this, whereas with the diatoms, you have a lot of different things that eat those. Or like, you have a lot of different things that eat the things that eat diatoms, like people and other different things. And like, their major thing is that they tend to increase in population as the temperature increases. One of the other interesting things that I found when I was like researching this was I did actually find a couple of papers that had actually done this study, but in different sections. So there was one that was over in the Caribbean Sea, and they actually, the Mediterranean Sea, but they found that a lot of their results were harder to pull because the nutrients there are a lot harder to change. Like, the sea itself is kind of messed up, so it doesn't really it didn't really follow into any of the procedures. Actually, that's it.
Great, thank you very much.